So, pleasure, guys. Those were little tiny companies I worked at, if you hadn't noticed. But short version of the story is I first ran into Scala and the Reactive stack when I was running the Advanced Analytics Offering Management Group, Product Management Group at IBM. And we were going through a pretty serious transition in terms of the capacity of development, the speed and rate and structure that we were doing things in. And I saw a tremendous amount of advantage to associating and using these technologies as a baseline to what we were doing. Got close to the company, really liked people like Kevin and the community and the organization that were part of it. And as soon as I looked around, I was working there. It was quite amusing. But we're going to depart a little bit from the core and the language and start looking at what's happening in terms of application of Scala and the ecosystem today, and talk about streaming, which has been driving a ton of the line of thinking and capacity that we've been working towards in terms of the community itself. So how did Lightbend and TypeSafe get involved in this process? Probably maybe two and a half years ago, there was a bit of an interesting revolution around this new and fascinating technology called Spark. And all of a sudden, at Lightbend, we saw a tremendous amount of increase in the number of support requests related to Scala and Spark, and said, hey, this is pretty interesting. We should really pay attention. We should be part of the process. Eventually, we got pretty well engaged with the community on the Spark side, started to work through some of the idiosyncrasies of that relationship, and eventually ended up supporting Spark as an element of our subscription offering. Made a lot of sense, but we also saw some inherent limitations, and we'll talk a little bit about that, and worked to start broadening the environment. At the same time, a lot of very key, not just direct development tools, but infrastructure and capacities and other technologies started to come forward, like Kafka and Mesos, Mesosphere, and DCOS, and we saw the ecosystem continue to grow. We were uniquely positioned, thanks to Scala more than anything else, to be able to help drive that. So we'll talk a little bit about what that looks like. What we started to see is what we called, really the emergence of fast data. So not necessarily what you would think of as big data. Big difference here is we learned a lot from things like MapReduce 10 or 15 years ago in terms of how to handle large data sets, but they were largely tied to a batch execution model that didn't scale in terms of the types and structures of applications that people were developing at that time. And there was a need to move to a more streaming-driven paradigm. That was driven largely through, transformative and web-scale development at a variety of very common names that are elements of the patterns and contributors to the communities that we work with on a regular basis. Places like Netflix, Amazon, and a variety of others. But the bottom line is that these are all people that contribute on a regular basis to extracting value and delivering capabilities to the marketplace. So that's been generally positive. At the same time, there was a general increase in the structure and nature of data and the need to move away from static, synchronous, or simplified systems and move deeper and deeper into the democratization of distributed systems programming as a part of that. Kevin's example of Walmart is an excellent one to help define that. These are just some examples of sources in those cases where we see things moving. That really pulled technology forward a lot and started to add to more common points of innovation in the space. It's no coincidence that, for example, finance has been an early adopter of functional programming in Scala. When I was at Morgan Stanley, the company made a decision to switch completely from Java to Scala, period, and all new development was moved in that direction at that time. This was almost 10 years ago. No big surprise that had a big impact on it. And companies like UniCredit here in Italy, also a sponsor of this conference, is doing some really innovative things on that front as well in terms of driving those things. And there's other factors that are going into this, which is when we couldn't work with big data and we still had to do streaming, we would limit the scope or type of execution that we were doing. So many trading strategies were based on interpretation of simply market data. What we're seeing now is an explosion of what people are calling generalized simulation in trading strategies. So you're bringing data in from external sources, news, weather, geographic surveys, all kinds of other scenarios, and actually modeling the systems that influence the relationship to the market, which brings a tremendous amount of complexity in both development and analysis. And without the ability to simplify the programming model that you use to operate on this, it's pretty much impossible to do. So, how are people implementing these capabilities? What does this look like? In many cases, it's a combination of trying to get to the simplest form of delivery of features, and that is starting to head towards what I would think of as microservices in many cases. Previously, we've always been building services, but those services haven't necessarily followed some of the advanced design parameters that are part of that package. So the thesis here is that services and big data architectures are merging. In many cases, the amount of data that you have to work with in any given state requires you to simplify that abstraction model and pull those together. And this merger has been, how do I say, potentially contentious ultimately. There's two different mindsets, and in many cases can vary in scope and structure, language, experience base, and a variety of stories. I met a gentleman outside earlier who comes from a data warehousing background, but he's going through the process of internalizing and learning Scala, primarily because it is the lingua franca of these types of tool sets, and it starts to extend the capabilities in those situations. So the first thing we need to consider in this context is the elements of building services, and this is really where the skills as application developers coming from the Java world and a variety of other sources really starts to drive. And that Java world is characterized typically by what we call a monolith. Monoliths are, again, large JEE applications. All of the components centralized in functions and components and functions are centralized in these cases, and they've been, in many cases at this point in time, developed over the last 10, 15 years. So much so to the point that being able to release a feature and put new capabilities in the hands of customers or users is pretty much impossible and or difficult to do. These systems are usually backed by synchronous data stores, which always makes it entertaining. Microservices is now the next level of this, which is to look at breaking this down, defining single responsibilities, driving towards methods of analysis like domain-driven design, and establishment of a bit of separation. General rules like each service owns its own data, the application of things like CQRS and event sourcing to help enforce that requirement, start to build on top of that process. And this is primarily done not necessarily to do anything different than the last application did, but what it does is it starts to make it easier to evolve these architectures ultimately and deliver value. Hence, we step in with the idea of reactive systems. Reactive systems are an expression of, in many ways, the core values of Scala and functional programming, but ultimately they start to extend to a system-level interpretation. So, systems need to be responsive, but they can't really do that unless they're fundamentally elastic and resilient. In other words, can scale both vertically and horizontally, and as well, expect failure as a component of the design structure was there. Kevin again talked about his implementation at Walmart with Play as a good example. Core to all that, ultimately, is to move away from a synchronous architecture, start implementing asynchronous and message-driven scenarios, and the Reactive Manifesto is probably the best core philosophical example of how we can describe that in many cases. Certainly not complete, but designed to be as easily consumable as possible. The next level of the story here would be data systems. So we've talked a little bit about services and microservices and how that is relevant to this structure, but data systems ultimately come from a different branch or branch of the tree, if you will, in many cases. So, just to go back for a second, Hadoop was great. In some cases, it absolutely still is. It's low cost, scalable batch analytics. It gives you the capacity to, store and manage things. It moves away from a very monolithic data warehouse viewpoint and allows you to pull a strong understanding of data management as part of this, but it still has all of the shortcomings of a basic batch architecture in many cases, and ends up being a transition point for landed state in some of the newer architectures. But the next question is, what if we want answers sooner than the batch model can afford you? What do you need to do? Well, that's really where streams processing starts to enter the picture and interpret its next level of value, ultimately. We took a look at this and we saw in the market many different instances of how this has fallen together, but ultimately probably the best general pattern we've been seeing is what's called the SMAC stack. So Scala, Mesos, Akka, Cassandra, Kafka, in many cases. That pattern allows you to handle the resilience and scalability that's necessary, as well as drive a lot of other approaches. At Lightbend, we've started to extend that definition because of some of the indices around things like Spark. So Spark is absolutely fabulous, generally up to about 500 milliseconds worth of latency, but below that, it can become onerous to tune. But it is, in fact, like everything else, almost the Java of the streaming world in many ways. It's ubiquitous, it enjoys a wide breadth of support, as well as the types of libraries and tool sets that are available for it, where Flink is rapidly catching up as part of that as well. Akka and the actor model-based system that we have also has an option called Akka Streams, which is essentially that model with the capacity to handle back pressure, which allows you to do actor-based modeling of streams processing capability as part of that process too. And things like Kafka also come with streaming libraries that are exceptionally good for organizing and handling the marshalling of record sets prior to execution, as well as the introduction of things like K-tables and aggregation as a function of the data that you're processing in this case. And then storage, if you're in a streaming world, just as if you're in an async architecture, doesn't necessarily have to be part of the call stack. It can be something that you use to land the product of your or the fruits of your labor, but doesn't necessarily have to worry about being transactional ultimately, which is the best part. So we saw this as a general pattern that that the market was moving to, and certainly started to describe the net effect of that. So let's test that thesis statement, which is fast data and microservices. Are they necessarily converging? Well, we've gone through the last probably 3 to 5 years of analysis-driven streaming. So the advent of what I would think of as modern data science has brought forward the new level of analysis, but it's also allowed us to start training models and work towards directly deploying them in applications and giving new life to what is ultimately the old school pattern of statistics that makes up machine learning in many cases. So not only do you want to be able to process large amounts of data, but you want to be able to include the results there as well. So there are many synergies between these two architectures in many cases. So every data stream app or microservice for that point, typically has one responsibility. It's defined as a pipeline that performs a function that's important. It always ingests unending data or messages as part of that. So there's commonality there. Each also has to be able to operate asynchronously, and it has to be to offer a never-ending service. It's also started to increase the total requirement in terms of your capacity to handle very stringent uptime concerns. We would all prefer to be able to, target to target 9 5s rather than 5 9s in terms of uptime in the apps we build, but that's not reasonable in this day and age. So both, they have similar design problems. They're dominated by data, and in the case of microservices, absolutely, from an eventual perspective. So we see a lot of potential synergies in those cases. So what does this mean in terms of the programming model and what you're doing today? Realistically, having a flexible programming model that allows you to handle these types of data sets easily and deliver these applications rapidly is absolutely important to the process. There are a lot of people working on this type of stack today. We're working with car manufacturers, we're working with finance teams, we're working with retail, we're working with a lot of different folks that have very common patterns of application in these cases and are starting to deliver on the promise of streaming enabled applications rather than simply a landed warehouse or other scenarios. So when it comes down to it, the story that we're looking at here is these services and big data scenarios are starting to push together. And that gives you a whole nother set of potential problems in this case, because what previously before was potentially a system of maybe 10, 12, 15, 20, even 50 systems, previously is now starting to grow to in the hundreds and even the thousands of nodes of compute as part of this process. So we're seeing much more application of things like Scala and data-driven languages in operations. So in many cases, there's good examples of that. So a very large red software vendor has just pushed out another interpretation of a public cloud centered on software-defined hardware and networking, and that entire project was built in Scala and Akka, for example. Another retailer / cloud vendor does all of its scalar operations and systems management with Scala. So I'm from Seattle. I spend a lot of time with teams from these types of companies, really kind of a cloud central relationship. So in application, the scope and applicability of Scala in these environments is continuing to increase, is really the summary. So we're putting together really a framework right now at Lightbend to take advantage of all of the prior art that you see in these cases. We're really pushing on the idea of making available, and as we've been talking about in many cases, the microservices framework that are necessary to do this, centered around really supporting the Scala developers and Java developers in this case. But we're also, in many cases, doing a tremendous amount of work coordinating with the enemy in some situations. We talk to Oracle consistently about the relationship of the features that are part of this process in Java today. So the Java 9 work that's going on and the planning that's happening past that, we really feel is pretty important to us for really one fundamental reason from the Scala perspective, which is the more features that we're able to push down into Java and the more functional that we make Java, the less the transition is when people start to move from their current Java base into the Scala scenario. I think some of the perspectives that have been shared today make a lot of sense, but ultimately, if we have to look at this that situation as a problem statement, the distance between a Java programmer and a Scala programmer, in many cases, if we can make that as small as possible, we're going to capture more folks, make this more ubiquitous, make it easier for you guys to focus on your work. Because one of the things that the Scala community does better than anyone else is drive and evangelize the capacity of its own tool set. And it's great for all of us in that regard. So on that side, it makes sense. Streaming is going to continue to evolve. We've been doing a ton of work with folks like Intel, who brought to the open market a project called Gear Pump, which was actually really distributed Akka streams ultimately. We've been doing a ton of work with Google, specifically on a next level of abstraction here on top of the stack, which is basically an abstract windowing toolkit called Beam, which is that expression. And we're really close. You know, Tyler and Francis, if you're listening, this type of community really needs it, but we've got them to tentatively agree to support Scala as a full-time, as a first-class citizen in the Beam API as part of that exercise too. So we're continuing to, you know, drive that scenario as well. You know, I mentioned earlier the clusters are getting larger. We have been investing in the types of telemetry and tooling necessary to continue to explore that problem. One of the things that's happening is there's so much ops on top of this type of complex stack that a new pattern is starting to emerge, what's called the operator pattern. The idea that you actually have to codify and define a set of relationships of the type of work that happens at the operations level, and then start, you know, traveling up the levels of abstraction on the operations side as well. And we'll talk a little bit about that also. And that's what we're doing here with something called Lightbend AI. It's the idea that these clusters produce telemetry that we can use to train models that can better describe and anticipate problems in terms of scale, configuration, and other scenarios as part of that too. So, you know, really the next level of objectives here is really self-optimization of this type of stack. We want to take away the complexities of delivering on top of a streaming application set and start pulling things into that sort of operator pattern when it comes down to it. So what does that mean? It means things like observing different components in the system, interpreting what changes in those components mean, and affecting change in other frameworks. We work closely with Mesosphere, with Confluent, with a lot of the folks that are behind these projects to start to interpret that. And we're trying to do this in a way that's, how would I say, orchestration framework neutral in many cases. So for us, I think the long-term objective of, you know, staying close to Mesosphere and DCOS is important, as well as understanding and recognizing the needs that you see in things like Kubernetes as a key component of a modern deployment stack in those cases. So, you know, this is what this looks like today. This is something that's not out. This is a product we're working on currently, but really the objective is to provide a platform for you to be able to develop rapidly complex streaming applications as part of the package and get a sense of where that goes. So in these cases, you've got a lot of options in terms of streaming. We talked a little bit about Kafka, Akka, Streams, Spark, and Flink, but there's a lot of other ancillary tools that are very valuable in these cases. We've invested time in something called Alpaca, which is a back pressure-driven source sync, a really very useful tool set to help you handle this. In that case, and that's not a commercial project, that's something that we do in our spare time right now from a community perspective. But all these things map together pretty tightly in terms of what that interpretation is. We're also investing time in things like model portability for machine learning. So there's been a fundamental issue with you know, trained models working on different streams processing frameworks. From a scoring perspective, we're working through that as well with Spark and Flink and a variety of other areas. So I just wanted to give you a sense of where some of the focus of investment from the Lightbend perspective is. That being said, you know, I think it was great to hear, and we are deeply appreciative of, you know, partners that we work with on a regular basis, like Type Level and Red Elastic and a few other folks that put effort into making sure that we're continually progressing this. We have a lot of competing priorities at Lightbend because we cover a lot of technologies, so we rely on outside influence to push and drive innovation through the channels that we have. So it's very important to us as well. And we're really quite excited to see things continue to progress on that front. there. So, what really comes next in this context? We're going to continue to drive growth and support for Scala. We have been working with very large organizations that can bring to bear a lot of additional horsepower in terms of developer reach and capacity. Google, Microsoft, Oracle, and IBM, for example. These groups have folks that have been building on Java-based stacks for a long time and have expressed a direct interest in providing a path to transformation for those teams. And we're excited to continue to push that from that perspective. And we really want to extend and preserve the principles of reactive systems and functional programming, therefore, as part of that process. So it's a continuous flow of good feedback and, frankly, challenging positions that the community takes that we rely on to keep us honest as well. So we're pleased to see that. And I think if there's anything that's happening right now that's pretty important is that there's a tremendous amount of downward pressure from essentially the cloud vendors today, in many cases, on infrastructure-focused or development-focused technologies. It's getting harder and harder on a regular basis to rely on the open market for innovation in these cases because it's very easy for someone to pick up a standard or a technology, build a project on a cloud vendor, and essentially democratize that without essentially paying back the community in many cases. So it's important that we continue to drive and work together in total to make sure that we continue to innovate together. And that's going to be through continuing to abstract and extend these viewpoints with things like Beam, with things like durable messaging systems like Kafka. There's places for us to continue to work in these areas and move forward. So I think it's important that we recognize your contribution as well from the Lightbend perspective. We wouldn't be here without you. So we humbly submit that it is because of you it's possible. So I just wanted to give you an overview and give you a sense of where things are going from that perspective. This is really the fundamental spin point for us in terms of how this works. This is just a representation of this part of the talk. We're continuing to invest consistently in Akka and a variety of other stories. But actually, how many people use Akka today in combination with Scala? So that's almost a majority. That's great. And I really think that's part of it. But we're also trying to, again, it's important to recognize projects like Lagom, which is the microservices framework, is designed to continue to build a groundswell of reactive viewpoint here so that we can continue to support and interpret the value of the core projects that we're working on in concert with the community. So that's what I had today. I figured I'd leave some time for questions if that would be amenable to the group.